I can take it. That's fine. Hello, everyone. Thanks all for being here at a talk called Understanding CSS Layout at what is predominantly a JavaScript conference. So in this talk, I want to help all of you understand the fundamentals of CSS. But before doing so, I want to get a little feel of the room. So who here thinks that CSS is difficult or hard? Yeah, okay. And who thinks that it's all easy when you have a really good grasp of CSS? Yeah, that's fine. That's fair. Okay, cool. Thanks. That helps me level the talk a bit. So when you look at CSS as a whole, as a system, it is very large. It is very complex, and that makes it really hard to understand. But as we all know, it's also a system that works. You don't have a system that's around for like 20 years if it doesn't work. So there is a law called Gall's law that states that all complex systems that work evolved from simple systems that also worked. And that's also the case for CSS. Over the past years, it has slowly grown in complexity. So CSS started as a single layout algorithm called normal flow. Now, normal flow has a few basic rules, which all subsequent concepts in CSS are built upon. So once you understand them, you can see the matrix. Or in other words, you go from this to this.
Only 2 minutes for the team.
Exactly, but now we got it. I am Kilian. It doesn't really matter what I do, and I don't really have time for this anyway. I do make a browser called Polypane, which is for developers. It helps you with responsive design, accessibility, and indeed CSS. Anyway, so in the beginning, we'll go over the fundamental concepts of CSS roughly in the way that they were introduced so that we can see how each new thing builds upon the previous one. And we'll start with this thing. Because the most simple concept in CSS is that everything is a box. Each element creates a box, and the x, y, width, and height of each box determine the layout. Now, stating that feels really obvious, but you need to understand that before screens were a thing, the idea of a live algorithm, a live layout algorithm, wasn't really something people needed. Of course, pages got laid out, but there was a person doing that, going, this goes there and that goes there, and it never changed afterwards. But none of that happened in real time based on a system of rules, which is essentially what CSS does. So CSS is a bunch of boxes. What's the layout algorithm that places them on the screen? Well, that's normal flow. I mentioned it earlier. So normal flow is the first and simplest layout algorithm in CSS. And it's the one you get when you don't do anything else. And it's from when the web was made for document sharing. And normal flow refers to the way text flows on a page. For us, it goes from left to right, top to bottom. There are, of course, languages that go in different directions, but for the purpose of this talk, I'm going to skip over them. So, from left to right is the inline direction, and from top to bottom is the block direction. And that's because text characters, they are side by side, they're in a line. So that's the inline direction. Whereas if you look at paragraphs and headers, they are block because they sit on top of each other. Now, browsers ship with a default CSS style sheet that dictates which elements are blocked by default and which elements are inline by default. P for paragraph is block and M for emphasis is inline. And that means that if you write semantic HTML, the browser already makes it look like a document for you. And that's why the first website that we saw earlier today still looks as designed as it was back in 1990. So block and inline will tell you how a given element lays out in comparison to the elements around it. But not everything is an element. So for example, in this bit, there's the paragraph, that's an element. There's the M with the word emphasized in it, that's an element. But that bit, that's not an element, that's just text. So how does that work? Well, earlier I said that in CSS, everything is a box. And that's also how normal flow solves it. If there's a thing that doesn't have an explicit HTML element, that doesn't have an explicit box, the browser creates something called an anonymous box around that text. Now in this case, it will be an anonymous inline box because the browser looks at where it is positioned. It's positioned next to another inline box. And then it knows that this anonymous box also needs to be inline because they need to be side by side. Now this is called the formatting context of the element. So if the code was this, there's a div with a paragraph in it. Both the div and the paragraph are block level. So the anonymous box generated for this will be an anonymous block box. And the browser can then lay out the two boxes on top of each other. So that's the anonymous box generation that CSS does for you all the time. And once you know that this happens, you suddenly start to understand why some things that you think are weird actually make a lot of sense. Now I'm sure you are all math geniuses, so you know that 50% plus 50% is 100%. So why don't these two boxes line up side by side? They're in line, they're 50% of the width. What's the problem, CSS? Well, if you look closely at that HTML, there's a new line between the first div and the second div. And that new line contains white space. And that white space creates an anonymous box. And now it's very easy to see that the two halves plus the anonymous box are more than 100%. So it doesn't fit. Now it would be great if we could say, target that anonymous box and get rid of it or make it a width of 0 pixels. But unfortunately, you cannot target anonymous boxes in CSS. They don't have a selector you can use. There are other ways to solve this though. For example, just literally getting rid of the white space. If there's no white space, there's no box being generated. And you can see that, hooray, now our math works. But you do need to do weird stuff with your HTML. What you can also do is tell the browser to, let's not wrap. Let's do white space, no wrap. Now this won't make them sit next to each other. There's still that anonymous box in the middle, but they're at least on the same line, right? Now, if you look closely, you can see that the total width is wider than the box. So maybe this isn't the right solution either. You can set the font size to 0 on the parent because the space character also has a font size. It might be invisible, but it has a font size. And if you set it to 0, then the space is still there, the anonymous box is still there, but it's 0 pixels wide. Then the math works out again. Now, if you do this, remember to put the font size back on for your child elements, or you'll spend way too long figuring out why your text doesn't appear. Now, this is the actual solution. white space collapse discard. And to show you how much CSS is still being worked on, white space collapse doesn't exist yet. It's part of the newest CSS specification, text level 4, and right now, white space collapse is only implemented in Chromium, but only the default value is implemented, which is what the browser already did anyway. The actual useful value, discard, doesn't exist yet. But it does mean that even normal flow, which has been around since literally the beginning of CSS, is still being worked on. Okay, now to everyone's favorite slide, the box model. I just told you a lot of stuff about boxes in CSS. Everything is boxes, there's block boxes, there's inline boxes, there's anonymous boxes. But what happens if we zoom into a box? So this is where we talk about the box model. You've probably seen this before. So a box in CSS actually consists of a few different areas. Now, for stupid browser reasons, there are two models when it comes to determining the size of the box. Content box and border box. One of those is the default, and the other one makes sense. It's just how it works. So the default content box, in this situation, if you set a width in CSS, that width is applied to the content. And padding and borders are added to it. So the actual width of your element will be width plus the padding plus the border. This is why most CSS resets have something like this in them, where we just tell the browser, make everything border box, because the math there is I set the width and that's the width. That's much easier to work with because you don't have to do math. This means, though, that in this situation, padding and border are both inside the box. So your content will be less wide. Usually this is what you want. This is like the logical thing. Margin is outside of this box, and we'll get to margin in a bit. But let's look at how these boxes actually get built. Because everything in CSS is a box. But box might not be what you think of as a box. So a block box makes sense. The element is a rectangle, and there is a border on all of the edges. But inline elements can wrap to the next line without becoming a block element. And so the box around an inline element also gets split up. The way you can look at this is an inline element will be drawn as a single line, as long as needed for the content. And then it's cut up into lines so that it fits the design, your screen, whatever. And if you cut up that inline box, what happens is that if you have a border, there's a border at the beginning, and there's a border at the end, but there's no border in the middle where you made a cut, because there wouldn't be, right? So this is why if you have a border or a padding or whatever around an inline box, weird things can happen, or things you don't expect. This looks pretty broken. Nowadays, which it wasn't always the case, but nowadays you can tell browsers how to treat each broken up line with box decoration break. Now the default value here is slice, which is, it's literally what they're doing. They're slicing the box up and stuffing it into new lines. But you can also tell it to clone the box decorations. And then each line will become its own little box. And we get borders and padding on each line. So however way you slice it, it's all just boxes and lines. So what is a line? Now each box in CSS is split up into lines, and these lines are based on the line height of the font in your box. Like this. 2 perfect lines. But if you look at the text doesn't sit on the line. And that's because each line has a baseline, and that baseline is determined by the font that you use. And that baseline is where all inline elements are aligned to, or they sit on the baseline, as you say. Now, baseline is the default vertical alignment for text, but you can also align to the top, the bottom, and the middle of a line, as well as the text top and the text bottom. And as you can see, the top and bottom are determined not by the line, but by the font. If you look very closely at middle, you see that it's not actually in the middle. And it's also not actually on the baseline. And that's because middle has this very weird formula that's being calculated from a combination of the font matrix and the line height. And because of that, it's not actually guaranteed to be the middle of the line. I'm very sorry, but that's just how it works. If you look closely, you can see that there's more space above the middle than below the middle. I'd like to apologize for that on behalf of CSS. For the purpose of this talk, we're just going to skip over it. This is now something you know, and you can cry about it later. We won't bring it up anymore. The important part is that inline elements sit on the baseline. And when you know that, when that is something that you understand, suddenly this situation makes sense. You have an image, it's in a box, and there's space below the image. That's weird, except it's not, because the image sits on the baseline, and as we saw here, the baseline isn't the bottom of the line. Now you know why. So what can you do about it? Well, most of you will do something like this, which is display block. Now this removes the image from the line, but as you can see, it also has other effects. Now it behaves very different. If there was text around this, it would have put the text above and below the image. What you can also do is make the line height 0. Because then, like the baseline and the bottom of the line, and the top of the line for that matter, they're all in the same place. So this is also a good solution if you don't have any other text in there. But the actual thing that you will want to do is get that image off of the baseline. You can align it to the top or to the bottom. And now it's no longer aligned to the baseline, and now it no longer matters where that baseline is, and there's no space around your image. Inline elements sit on the baseline, and if you don't want that, you use a different vertical alignment. Okay, so we haven't done enough weird CSS stuff yet, so let's talk about margins. So margins sit on the outline of an element, and they help push boxes apart. For block elements, this happens in all directions: left, right, top, and bottom. But inline elements sit on a line, and that line determines where their vertical placement is. So adding a margin to them will only add margin in the inline direction, to the left and to the right. Now, there are more weird things when it comes to margins. For example, margin collapse. A thing that was deemed useful in CSS was that if you have two margins on top of each other, only the larger margin of the two counts, and they collapse into each other. Now, this happens not just when there are two elements side by side in the DOM, as it were, but it can be any two elements that have the same formatting context. Remember from like 10 minutes ago with the anonymous boxes, where the anonymous boxes looked at their formatting context? Well, that also influences margins. And that means that if you have, for example, an element with a top margin, and the parent element also has a top margin, those two get collapsed as well, because they share a formatting context. What if you don't want to do this? Well, you can force them apart, because as soon as you add, for example, a little bit of padding, margin collapse no longer exists. Or you can be explicit and set an overflow strategy with, for example, overflow auto. Now, setting an overflow of auto creates a new formatting context. And because margins only collapse when they're in the same formatting context, and we've now created two, one for outside of the element and one for inside of the element, the two margins no longer collapse because they're in different contexts. We have collapsing margins, but we can also have negative margins. Negative margins are even weirder. Because when you use negative margins, you aren't adding space between elements, but you're actually changing the position of an element. So the way negative margins get calculated is by taking the collapsed margin value, so margin collapse is still very much in play, and then subtracting the negative value, and then instead of pushing them apart, they move the elements to that calculated position. Now, I'm showing this because negative margins exist, but you're better off ignoring them and using positioning instead. So more on positioning later. When you want to horizontally center a block level element, you can add margin auto. I'm sure all of you know that. And that will add the same amount of margin on the left and on the right of the element, thereby centering it. But why does this work? This works because horizontally, all block level elements use a constraint-based layout when either width or margin is set to auto. So what is a constraint-based layout? A constraint-based layout essentially means that there's a little formula that gets solved, and that then determines the layout. Now, this is the complete formula, but border and padding are static, so we can simplify this. The formula for every block level element, its horizontal layout, is margin left plus width plus margin right need to be in balance. Now, if you set all of them to auto, the width will take up the full horizontal space, and the margins will be 0. And this is because the preferred width of a block level element is the entire width. It will try to fill the space. So the math becomes 0% margin, 100% width, 0% margin. But as soon as you constrain the width, if you set the width to 200 pixels, the remaining space is divided across the margins. So if both are auto, they get the same percentage. But if one of the margins is defined, the other gets set to whatever is left, because it needs to solve that formula. And you can see that here, where the element is right aligned, despite block level elements normally starting on the left, because of normal flow. But because we've defined both a width and a margin right, the browser will fill in the rest of the formula for us and determine that margin left will have to be this wide to make sure that the other constraints remain true. So that's how inline margins work. So there's one last trick that normal flow has up its sleeve, and that is that an element can also be inline block. Now, given all the time that we spent figuring out what is block and what is inline, what even is this? Well, inline block tells the browser that a given element behaves as inline for the formatting context around it, but it is rendered as a block box for the content inside of it. So it sits on a line, and you can see that the word box is perfectly aligned with this is a line, because it sits on that line. And the element is as wide as the content inside of it. But you can still apply margins and padding, etc. to this inline box, or inline block box, I should say. Now, the specification calls this shrink to fit, and it's essentially a sort of proto-Flexbox. If you go back, you'll see it is most often used for like lists of tags, etc. So that was CSS' most simple layout algorithm. Would you have expected that there would be so much behind what essentially boils down to text goes from left to right, top to bottom? Now, the good news is that all other layout algorithms build upon this concept. In fact, unless you explicitly take an element out of flow, out of normal flow, they are considered to be in flow, and the normal flow layout algorithm is used in addition to whatever else you use. So whatever else is there? Well, we've done normal flow. You can do layout with tables and floats, but we're going to pretend that that's not an option, because it's not an option. Then there's positioning, flex, and grid. And for the rest of this talk, I will focus mostly on positioning and end up with some information on flex and grid. But I won't be doing like another explanation on how flex and grid layouts work, because then we'd be here for like the rest of the evening. So with positioning, we can tell the browser how to place an element, either in relation to whatever position it would have been in, its calculated position in normal flow, or we can explicitly take it out of normal flow. And positioning is also where the third dimension is added into CSS. The Z index doesn't exist in normal flow. And with that, we can decide how elements stack on top of each other. Now, elements by default have a value of position static, which means that they have no explicit positioning. And to activate the positioning layout algorithm, we need to pick one of the different values. And each value is more or less a different scheme that makes your element behave differently. They're like mini layout algorithms. The basic value that you will want to use is called position relative, because that essentially lets you opt into positioning layout. Now, a relatively positioned element will have a box that's placed in the same place as normal flow. It's that darker box over there. But we can move that element with top left, bottom and right away from its initial place. Now, it works differently than margin, which will also let you do that. But as you can see, while we've moved the box away from its original place, it's the original box that determines the rest of the layout. Now, you will rarely do this because it's very confusing. What you will use position relative for is to make an element something called offset parent. Before we get into what an offset parent is, let me explain position absolute. So with elements that have position relative are still in normal flow in your document, but absolutely positioned elements are taken out of normal flow. That means that they do not interact with other elements anymore. We still have the same two text lines with the box in the middle, but because the box is now positioned absolutely, it doesn't take up any space in the rest of the layout. Now inset, so top left, bottom and right, doesn't move the box away from its reserved space, because it doesn't have a reserved space anymore, but it places it in relation to the offset parent. So the offset parent is the first ancestor, so the first element around it, that is also positioned, that also has a position value other than static. And that's what absolutely positioned elements are positioned in relation to. Now by default, your body element is the offset parent. So you can see here that I've set a top for my child, and that top is in relation to the body, because that's the closest offset parent. But if I then add positioning to the parent element, that becomes the offset parent, and because it's closer to my child element, in this case, it becomes the offset parent. And now the top sits on top of the parent element and no longer on top of the body. Now, position absolute also makes the element itself an offset parent. And if you have problems with positioning your elements absolutely and they're not in the place you expect them to be, it's because you don't realize which offset parent you're using. And figuring that out is really easy, because you can open up the console and you can ask any element, what is your offset parent? And it will return the element for you. And then you can click through to the elements panel and fix it. Speaking of fixed, fixed is very much like position absolute. Elements are taken out of normal flow. But in this scheme, the offset parent is always the viewport. So top, bottom, left and right are used to position from the edge of the viewport, from the edge of your browser. And that means that while absolutely positioned elements will scroll along with the rest of your page, fixed elements always stay in view. I think I can scroll here. Yes, look at that. The page scrolls, but the fixed element doesn't. Magic. The last scheme for positioning is position sticky. Now, position sticky was added much later, and it's for elements that you want to keep in view some of the time, but you still want to scroll them along with the offset parent. So with position sticky, the element will be placed much the same as position relative, but the top, left, bottom and right values will determine where an element gets stuck and sticky. And that is relative to something called the scrolling context. CSS is very context dependent. Now usually your scrolling context, the thing that scrolls is the page, your viewport. So you can see as I scroll here, the element scrolls along until it's at like 100 pixels from the top, and then it just stays stuck. Now, a tricky thing with position sticky is that things can only get stuck if the browser can determine when that is. There are three scenarios that can cause issues where you think an element should get stuck and the browser thinks that you can't. So if you have a parent with an overflow of auto or hidden, then you create a new scrolling context, and so the element can no longer be sticky against your viewport. If the element that your sticky element is in doesn't have a fixed height, then the browser doesn't know when it reaches that threshold of top, left, bottom, and right. Then it also doesn't stick. And lastly, and this is actually a really nice one, if your sticky element is too large, too high to get stuck, it also won't get stuck, because the element needs to be visible for it to get stuck. And if it's not fully visible, the browser determines that it should just scroll along with whatever its parent element is doing. Now, so far we haven't yet discussed the third dimension, other than mentioning that you now have a z-index. Hooray! So while the concept of an offset parent tells you how an element is positioned in the x and y directions, the stacking context tells you how it gets positioned in the third dimension, how close it is towards the front of the screen. And like offset parents, you can have stacking contexts inside other stacking contexts. So by default, elements have a stacking context order that's the same as the source order. So if you have a div with a before and an after, it's the before, then the div, and then the after. But you can use z-index and flip that around. Now that reordering only happens inside of a stacking context, and there's no way to break out of a stacking context. And that's somewhat similar to CSS specificity, where one ID will always trump however many CSS classes or elements you add. So if you look at these, there's 3 elements. One has a z-index of 1, one has a z-index of 99, and the other has a z-index of 2. And that z-index of 2 is still on top of the one that's 99. Because it is not actually 99, it's 1, comma, or 1.99, which is less than 2. So you can only order items in the same stacking context. Now there are a few CSS properties that cause stacking contexts. I will leave this up for a while so you can memorize it. This makes offset parents sound really easy, right? Just positioning and you're done. Now this is quite a list, but most properties aren't used very often and they're used for very specific purposes. I'll leave it up slightly longer for those that can't memorize it. So the 3 you really have to care about is positioning, z-index, and opacity, because those are the things you use most often. And these are the 3 that you will want to check first if you have stacking context problems. Out of all of the ones I listed, isolation isolate is the most explicit one to say specifically I want a new stacking context. Kind of like how position relative is the most explicit way to say I want a new offset parent. So let's dig into how that works. So I have here a design with a quote, and I have it positioned correctly in the X and Y direction. There's a box and there's a quote, and I have a nice little quote icon in the top left. Now we can see that the quote is in the right place, but it's in front of the text, and I want it to be behind the text. Now, unfortunately, we can't target the text itself because the text is an anonymous box. We can't target anonymous boxes with CSS. So we can't bring the text forward. We need to bring the quote to the back. And we can do that with a z-index of -1. But when you do that, the quote disappears behind its parent element, because the stacking context is the HTML element. And a z-index of -1 will place it right at the start of that stacking context. So even if my quote is inside of a div with a background, I can put it behind that background. So what we need to do is we need to make that parent element the stacking context by adding isolation isolate to it. So now the quote is still placed as the first item in the stacking context, but only inside of the parent element. Behind the text, but before the background. So finding the stacking context parent is not as easy as finding the offset parent, because unfortunately there is no equivalent DOM property that you can find with your console. So I built a debug panel in Polypane that tells you the stacking context. And that makes it really easy, and that's all the promotion I'll do. Please check it out. So now you know about the fundamentals of CSS layout. You know about the different types of context something can be in, and how that affects where elements get positioned. You know how normal flow dictates element placement, and how display and position allow you to opt into different placement schemes within CSS. Now, Flex and Grid are built upon these fundamentals, but they don't replace them. So let's quickly go over how they interact with these CSS fundamentals in the last couple of minutes that I have left. So as I said, what I won't be doing is teaching you Flex and Grid, because that's a very large topic. What I am going to tell you is that Flex and Grid are significantly different from the layout algorithms that came before, because both have been developed not as a way to lay out documents, but as a way to lay out web applications. Now, conceptually, Flex takes a bunch of elements and then lays them out in a way that you describe. Grid creates a bunch of areas and then puts elements inside of them. Additionally, Flex is also one-dimensional while Grid is two-dimensional, but that's not super important for understanding how they operate. Now, in this sense, they are both a replacement for normal flow, but they're a much more explicit way of telling the browser which elements go where. What's interesting is that both Grid and Flex have changed the way alignment works to no longer be dependent on the font, which obviously is a logical choice for documents, but it's not a logical choice for web applications or UIs. So alignment in both Grid and Flex are based on the generated boxes. And that's why aligning things in Grid and Flex is so easy. Now, both of these also try to make sure that regardless of what element properties you have, the layout you chose is preserved. And that means that, for example, if you set a width on an element, Flex might decide that that element needs more or less space, and then it will make that element larger or smaller, depending on the rest of your Flex configuration. In Grid, that width is just going to be ignored because the grid is responsible for your layout, the grid is responsible for the size of each area, and the elements are just placed inside of it. So since both Flex and Grid are display values, you go from display block and display inline to display Flex and display Grid. The way to determine something like an offset parent or a stacking context doesn't change. It's exactly the same as for normal flow or precision elements. And you can also take an element out of Flex layout or Grid layout by changing their position to absolute or fixed. And each element inside of a Flex or Grid layout, including a Flex and Grid element itself, can be set to position relative or position absolute. They can have isolation added to them, and they can become offset parents in stacking context themselves. So they work alongside all of these rules in normal flow and positioning layout. Now, one thing that Flex and Grid make much simpler is aligning, and especially vertically aligning something, because it no longer looks at the font, it just looks at the boxes. And that's why something like align item center is so easy. Now, align items works both in Flex and Grid, and this works so well that instead of just keeping it in just Flex and Grid, browsers implemented it in regular block elements as well, with the CSS box alignment module level 3. So now for any display block box, you can say align content center, and that also works. So vertically centering anything anywhere in CSS is now trivial. It's literally one line. This update to normal flow got added into all the browsers earlier this year. So those are the fundamentals of CSS Layout. You can find me on Twitter as @Kilian Valkhof, and if you have questions, come and talk to me afterwards. Thank you.